Hello everyone, dear authors and invited guests. Welcome to Technical Session 5B. Myself, Ayush Garg, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 7th World Conference on Smart Trends in System Security and Sustainability, WS4 2023, London, UK. The 7th edition of the conference is being organized in a hybrid mode. The physical event was held in London, UK on 21st August 2023, and the virtual event is being held through Zoom today and tomorrow, is 23rd and 24th, 2023. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have six presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for question and answer. On 10th minute, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in chat box. Just before we start the session, I would like to introduce you all to the chair of the session. Dr. Vivek Tiwari is an assistant professor of computer science and engineering at International Institute of Informative Technology. Near Raipur, research interests include data mining and warehousing, pattern mining and warehousing, data analysis, pattern retrieval, and presentation, machine learning, big data. Our another chair is Dr. Kesar. I welcome you both, sir. So, if you want to introduce yourself for 1 minute, you are open to do so. Mr. Vivek, sir. Moving forward with paper, I would like to call Diana present her paper on 3D design of a dental crown with artificial intelligence based in cloud space. You may please start your presentation.
Okay, I will share my screen. Everyone see it? Hello?
Yes, ma'am. Your screen is visible and your voice too.
Okay. Hello to everyone. My name is Diana Pavlova. I'm from Dental Private Dental Clinic from Varna. Uh, the article is 3D design of a dental crown with artificial intelligence based in cloud space with my team Tihomir Dobromachev, Dima Daskov, Nikolai Mirchev, Ivan Pev, Yulia Radeva, Rozavina Djilva, Kalina Kavalcheva, Beata, Gual Zuba, and Andromas Pandjul. Uh, we start to just a moment. Um, we work to this uh, this paper. Abstract is Industry 5 now brings to the human factor into the direct collaboration with artificial intelligence. This synergetic relationship also has a strong presence in dental health in the restaurants of decayed teeth. Related to dentistry, the importance of the CAD-CAM system and 3D printers also have greatly improved the production process in the dental laboratory. Intraoral scanning, obtaining an imprint of the prosthetic field, and change the comfort of the patient during manipulation in the dental office. Here is the speed of making a dental crown, which will seal the damaged structure, also effective successful completion of treatment damaged tooth. The digital design process includes operator action that can be optimized the use of artificial intelligence that identifies the contours of the crown and the border between the tooth and the gum. of the digital imprint, the position of the teeth, as well as distance from the antagonist. And this is the report attempts to bring all these aspects together, providing the real example from the field and driving important conclusion. Continuous advice in technology have revolution many industries, and dentistry is no exception. The integration of computer-aided design printers has significantly changed the production process in dental laboratory, enabling more accuracy and efficiency fabrication of dental restoration. The intraoral scanning technique has improved patient comfort during dental procedure, will increase the accuracy of data transfer by eliminating the need for traditional analog silicone impression. A critical aspect of dental treatment is the fabrication of dental crown, which play a vital role in restoring the damaged tooth structure. The ability of speed of the crown fabrication process is essential to ensure timely completion of treatment and patient's satisfaction. This is where the digital process coupled with the implementation of artificial intelligence also, the importance of technology advice is critical to consider the human factors involved in the design and manufacture of dental crown. The expertise of dental professional in interpreting digital impression, identifying crown contour, detecting tooth, the gum, bonders, evaluation tooth position, and determining antagonist distance is unavailable, ensuring the accuracy and function of the final dental crown. This paper explored the integration of artificial intelligence in cloud-based environments and CAD/CAM technology. In dental crown design, the research team explored the role of human factors in optimizing the digital design process, highlighting the importance of combining human expertise with AI assistance by understanding and harnessing the interplay between technology and human skills. The process can improve the efficiency, accuracy, and patient outcomes of dental crown manufacture. In the effort to optimize the digital design process for dental crown and international consortium of experts from Bulgaria, Hungary, Poland, and the UK have combined their collective experience in human factors and artificial intelligence. This cooperation represents a harmonious blend of expertise combining the knowledge and skill of dental professional with the transformative potential of Industry 4.0 and Industry 5.0. Industry 4.0 characterized by the integration of cyber-physical system to Internet of Things. IoT and cloud computing has already revolutionized the manufacturing sector. By leveraging this technology, the design and manufacture of dental crown can be further enhanced to real-time data collection, remote monitoring, and seamless connectivity between different components of the manufacturing process. The application of Industry 4.0 principle is in the dental industry ensures improved efficiency, productivity, and accuracy in the crown manufacturing. Technology dentistry. The consortium cooperation and use of advanced technologies such as CAD/CAM and artificial intelligence illustrated by real dental treatment presented in the study. This case study highlights of the successful implementation of this advanced technology in the design and manufacture of dental crown and demonstrate their efficiency in improving treatment outcomes by using CAD/CAM technology. The digital dental design become we go for streamlit and precious. Streamlit precious, enabling accuracy and digital design processing because more streaming and precious enabling accuracy and personal crown fabrication. The integration of artificial intelligence further enhance the efficiency of the design process by assisting in crown contour identification, tooth gum border detection, tooth position, and antagonist distance measurement to this cooperation between the international research, academic network, and industry leaders. Such at Denta Prime Clinic industry provide us a triangle example how to application of modern technology can significantly improve the dental care. One, the patient digital impression of the mandible and bite have been created in the STL file together with the treatment plan and order from the data package. Is generated in DCOM for the medical team. The generate file can be checked by the doctor, and the dental technician can check the accuracy of each file by opening in the T-shaped dental design software. Technical realization by integrating qual space processing, i.e. algorithm and user-friendly design interface. The streamlit digital workflow enhance the efficiency and the pressures of crown fabrication is combination the benefit of digital design with traditional manufacture. Traditional manufacture, and I explain the program how started. The program starts with a step that automatically identifies the border between the tooth and the gum, which will be and offer optimized border underline and with a green border in the goes to the process of creating the optimal crown design in a second. In them goes to the process of creating the optimal crown design is a second, and when the crown is ready, the software offers an option to accept, reject, or edit the design. The finished file is generated in STL format. Once the STL file is received, the process of creating the three-dimensional geometry of the crown is carried out of the conventional way using 3D printer or CNC machine, depending on whether temporary or permanent crown and models. And this is first clinical case. Figure A, show a view from different position of the field. Figure B, the offer of T-shaped automat with clinical crown design to 24. C, tooth with occlusal and approximal contact. The color scheme show with the distance. And final result, tooth 40, 24. Figure 2 explain second clinical case, tooth 25. Figure A explain the 25 four-dimensional view with outline of marginal border with green line. To figure B 25 split view position to the review the crown design. To 25 color scheme across show approximal contact and occlusal contact. And figure 3 clinical case 3 proposal explain the same step with a different type of tooth. 46 tooth show the internal situation of the intraoral scan before they are sent to T-shape automat. Proposal of the cervical contouring software. Proposal of the occlusal approximal contact intensive is determined, and digital design. Finally, digital design. of the crown.
Apologize for the interruption, but you have left only 2 minutes. Kindly
uh,
conclude your session.
okay. And the result, the implementation of digital work for dental crown fabrication using cloud-based processing, AI algorithm, and advanced design interface has yet significant positive result, improve the efficiency, accuracy, and overview patient satisfaction, improves communication between the medical team and the dental technician, eliminates the need traditional analog silicone impression, reduce the patient discomfort and potential errors associated with the manual impression techniques. The use of T-shape dental manager software in the digital workflow plays a critical role in ensuring the accuracy of the file received. The use of AI algorithm in the crown design process has proven to be very beneficial. Um, Using the real-time feedback provided by the software during the design process is unavailable. Using 3D printers and CNC machine temporary and or permanent crown can be accurately reproduced in the 3 dimension. Conclusion, the consortium commitment to future advanced AI technology in relation to human factors, particularly in the context of Industry 4.0 and Industry 5.0, underlines its detection to drive innovation in the industry by bridging the gap between technology and human capabilities. They are aimed to push the boundaries of what possible the design and manufacture of dental crown, ultimate improving patient outcomes and experience. This article serves as a valuable research and stakeholders in the dental industry, dental professional research industry leaders and policymakers. Makers can gain insight into the potential of dental workflow, its positive impact of dental crown manufacture. Acknowledgement to our partner, Erasmus project, cooperation partnership, Ergonomics and Human Factors Regional Education CIPUS Network, Bulgarian Association of Ergonomics and Human Factors, Dental Prime Dental Clinic, Bulgaria, Dental Prime FT3 Dental Implant Clinic, UK. Many reference, and thank you for your attention.
I request Vivek sir, if you want to ask any questions, you are open to do so for next 1 minute.
Okay, I'm waiting.
Moving forward with the presentation, now
Okay.
I would like to call Isim Mizanur to present his paper on cognitive model, predictive learning, operative control to optimize electric power consumption and user-friendliness in human-robot co-manipulation. You may please start your presentation.
Hello, hello, good morning. So do you hear me?
Yes, sir, we can hear you.
Okay, thank you very much. So I do not see the presentation slides that you are showing. Do you ask
Sir,
me to share
actually,
my own?
yes, sir, you have to share your own slides.
Okay, thank you. Okay, now I am sharing. So do you see now my
Yes, sir.
slides? Okay. Again, so I am just verifying that you please confirm me that you see my slides. Okay.
Yes, sir, we can see your slides.
Okay, thank you very much. Thank you. My name is Mizanur Rahman. I am from the Pennsylvania State University. So now I will be presenting my paper So let's see. So, okay. So I will be presenting my paper, Cognitive Model Predictive Learning Cooperative Control to Optimize Electric Power Consumption and User Friendliness in Human-Robot Co-Manipulation. So let us see the background. So why it is coming, this one. I do not need it. Okay. Okay, so let us see the background. You see that I am actually working with power assist robots. Power assist robot is a special type of robot where a human and the robot can work together, and the human and the robot can augment the performance of the robot can augment the performance of the human. For example, a human is manipulating an object in collaboration with a robot. And if the robot is a power assist robot, then the human will feel that the object is lightweight, lighter than the actual weight. For example, the object is 10 kilogram, but when the human will manipulate it in collaboration with a power assist robot, the human will feel that it is maybe 1 kilogram or 500 gram. So it means it reduces the haptic weight perception of the human, and in this way, it can benefit the human, and human can easily manipulate the object in collaboration with a robot. So this is a great advantage of the power assist robot, that it can augment the performance of the human. It can make the object lightweight so that the human can easily manipulate. So this is the good side, but there is also a bad side, that human does not know actually how much weight the robot will reduce. That means what the reduced weight will be, human does not know it. Human thinks that the object is very heavy, so human applies a large force to manipulate the object, but actually the human will feel that the object is very light, so the applied force will be larger than the actually required force, and as a result, the motion will be uncontrolled, and the motion will not be good, it will be dangerous. And this dangerous motion can reduce user friendliness, it can increase accidents, and it can reduce human-robot interaction. So this is the limitation of this type of robot. If we cannot control it, it will not be good, it will be bad instead. And another problem is that when we use this type of robots in industry, then electric power consumption or electric power efficiency is a great issue because there are many robots in industry, and gradually it is taking huge amount of power. So then electric power efficiency is most important. Otherwise, it will not increase the productivity, rather it will decrease the productivity. Unfortunately, there is no good computational model to compute the electric power efficiency. And also there is no good control method to automatically optimize the electric power efficiency of a power assist robot. So considering these limitations that we know from the literature and that we also know from our previous work, so the objectives of this research have been decided in this way, that we want to propose a cognitive cooperative control to improve user friendliness and human-robot interaction. We want to propose a computational model to compute electric power efficiency, and we want to propose a reinforcement learning based model predictive control model to optimize electric power efficiency and to verify the effectiveness of the proposed control strategies experimentally. So these are the objectives based on the literature review, considering the limitations of the current status of the power assist robot. So this is our experimental device that we have developed, and we actually used this robot in our previous work, but we are also using the same device for this research, but our objective is different for this research. So this is the system modeling. So the first equation shows the equation of motion, and the second equation is the simplified version. But the third equation, you see that we have two M1 and M2. Usually we use the same M for the inertial force and the gravity force, but here we hypothesize that we have different M's, M1 and M2, where M1 and M2 are not the same. We hypothesize this because there is a mismatch, or there is a difference between the haptic weight perception and the visual weight perception. To compensate this, we hypothesize that the mass parameter used in inertia should be different from the mass parameter used in gravity, and this can compensate the lack of user friendliness. And this is why we call it a cognitive modeling concept. It is basically a system modeling, but we use the human cognition based on weight perception, and as a result, we think that the M1 is different from M2. This makes it a cognitive modeling of system dynamics. So based on that, we developed a control method, and this control is nothing but a very basic position control method. I think that the position control, but here we call it also cooperative control, because the control parameters are partly come from human and partly come from robot or the software. So here human and robot works together, and as a result we call it a cooperative control. And it is cognitive because you say that we have two different M1 and M2 based on the human cognition. This is why we also call it a cognitive model. That means we call it a cognitive cooperative control model. And we implement it. And after that, we have a computational model that can compute the electric power efficiency. This is the model. Here we have different parameters like the torque, the velocity of the manipulator, the mechanical efficiency, the electrical efficiency, like this. So we propose this as a computational model to compute the electric power efficiency of a robot, power assist robot, when it works in industry in collaboration with the human. And after that, we have a model predictive control that is called MPC that we propose and that we can implement in conjunction with our position control. And here we also call it the reinforcement learning based MPC, because the model predictive control, what it does, it actually determines the appropriate velocity. Actually, it proposes it predicts the robot velocity that is most psychologically appropriate for the human, and how psychologically appropriate it is, we learn it from a reinforcement learning database. This is why we call it an MPC or model predictive control that will optimize the velocity, and we determine the standard velocity based on a reinforcement learning model. This is why we also call it MPC adjusted with or augmented with reinforcement learning or model predictive learning control. So then we implement this, and then we have two conditions. In the first condition, we implement cognitive MPC with learning module, and in the second condition, we implement cognitive MPC without learning module, and we measure the electric power efficiency using our model. And we see that the cognitive MPC with learning module reduces the electric power consumption or increases the electric power efficiency. So I think that yeah, so then cognitive MPC with learning module with actually takes lower, I think that lower electric power.
Excuse me, sir.
Yeah.
I apologize for the interruption, but would you kindly consider concluding your presentation as we have only 2 minutes left?
Okay, sure. Thank you. So then we see that we see that our cognitive MPC is better than cognitive MPC without learning is better than with learning is better than without learning model, and we also measure the user friendliness using in the subjective way using a Likert scale, and we see that the MPC with learning has better user friendliness over the MPC without learning. So then we conclude that in this way, we conclude that the results showed that both the MPC with and without the learning-based approach produce satisfactory power efficiency and user friendliness, but the MPC integrated with the learning module outperformed the MPC implemented without learning, without integrating the learning module in terms of power efficiency and user friendliness. So in the future, we want to augment it for multi-degree of freedom system, and we want to make a better database to learn more about the standard velocity using another reinforcement learning model based on more data so that the results are more accurate. So this will be our future work. So if you have any question or comment, I would be happy to answer the question.
Mr. Mazroor, I request you to kindly check your chat box as Vivek sir have some issue with the mic. So he will ask question in chat box.
Okay, so so there is a question. Okay. So what is the computational cost complexity of presented cognitive model? Computational cost complexity, because we have very limited amount of data just to show the effectiveness. So this is why it was not so costly. But if we have more data, that will increase the accuracy, but it will decrease the, I think it will also increase the complexity. So and it may slow down the system because it is real time. It will slow down the system. That will be the cost. And how to quantify user friendliness? Actually, it is not quantified. Here we used it as a subjective evaluation model. We used a Likert scale. So it has been quantified using a Likert scale, but it is still subjective. And so then it is suggestion more quantitative results are required. Yes, some results are quantitative. For example, the power efficiency is quantitative because that has been computed based on a computational model. But the user friendliness it is quantitative, but it is subjective. It is not objective. Because user friendliness, it is difficult to measure, but we measured it using a subjective evaluation method based on a Likert scale. So it is a cost is not related to data. Cost, I think that you may say the solver or the controller or the quality of the controller, but I used very small amount of data. It is actually not huge database. It is a small amount of data. So in this case, it is cost effective. So I think that, yeah, it is I think MPC itself is very complex. So then if we have huge amount of data, so it may be, I think it may be, it may slow down the system. That is the point. And it may need a more computing tool or computing speed. Okay, so thank you very much for your question.
Thank you so much, Chair and Presenter. Now, moving forward, I would like to call Tawfiq Safar to present his paper.
Yes.
The topic of the paper is design the feasibility of migrating cloud computing to the use of IT infrastructure using the cost-benefit analysis method. Case study, telecommunication industry. You may please start your presentation.
Okay, let me show the presentation. The sound is clear and the presentation is on. Please let me feedback the presentation and the voice. The
Yes.
mic. Yes, okay. Everything is okay. Okay, let me start the presentation. I'm Taufik Safari Dayat. I'm from Telkom University in Indonesia. Wait. Okay, I'm Taufik Safari Dayat. I'm from Telkom University in Indonesia. My journal or publication is about the designing feasibility of migrating cloud computing in the use of IT infrastructure using cost-benefit analysis method. In this case, we are using a case study in the telecommunication industry. Okay, the telecommunication industry is currently undergoing major to shifting to the cloud because to improve operational efficiency, scalability, innovation, and enhance the customer experience. The migration has a new challenge also in terms of investment, more of course, and to handle the security system, difficult to system integration and change in the work culture. Cost benefit analysis can be used to understand the cost associated with the tangible and intangible benefit received by a company. This method would help organization to decide whether to use the cloud or not. The result of this study revealed that cost benefit analysis can assist company in making decision to going through the cloud infrastructure or no. Because this decision consideration some item based on cost or benefit which are calculated, for example, like reducing cost, investment, improving performance, developer productivity, accelerating software development, and reducing system disruption. Yes, as we know, cloud computing is a model of delivering computing resource, including server, storage, database, network, and so on, via the internet or the cloud. The cloud computing itself has many advantages such as scalability, flexibility, cost effectiveness, and so on. But some paper written that reveals several things that make adoption of the cloud is not expected. Example of the lack of regulation, fear of losing job, and uncertainty about the usage or cost. Other studies emphasize that users often lack cost transparency and are unable to make a decision about the cloud computing adoption. As we can see in the iceberg in the right picture, on-premise infrastructure is the infrastructure in the private environment or on the company, and the right is a cloud computing. In the iceberg, in the surface, we can see the 9% software license is
Mr.
very
Tawfiq,
small. Yes.
actually, you are on your slide one. Your slide
No,
is not moving.
oh, not moving. But okay, let me. But I already share.
Now it's
Can
moving.
we? Now it's moving.
Yes.
Okay. This is sorry. Wait. This is page 4, yeah. Sorry, with cloud computing in brief. Page. The slide is showing, yeah. Correct me, Pak. Wait. Okay. This is full screen mode, ya, Pak. Correct me. Can
Yes,
you
it's
see the
done.
slide? Okay. Let me continue to the slide. The cost benefit analysis is a systematic process to evaluating the cost and benefit in a project, policy, and investment. It's technique to determine whether the benefit and of a proposed action outweighs the cost, whether action is worth pursuing. Cloud computing, sorry, cost use from cloud computing come from hardware, software, and several service, and several study also discuss the cost differences between the use of local computing and cloud computing. Implementing the cloud computing also consider benefit which include productivity, agility, innovation, and business excellence. Nah, let me introduce Indonesia is emerging country with significant potential in the telecommunication industry due to several factors like large population and the market, increasing internet penetration, economic growth, investment opportunity, digital in transformation, and so on. And we we are use some sample in this case, some company XYZ is one of the largest operator in Indonesia telecommunication industry, with a market share 60%, which is the currently carrying out digital transformation by migrating to cloud computing. In this case, we can study the cost benefit analysis in this enterprise. Approach this research is quality. Okay. Okay, qualitative research approach, conducting literature review and interview expert. We expert the interview were conducted with practitioner, IT infrastructure architect, application manager, and cloud service provider. Nah, this is method to interview, like 5 why and why, what, who, where, when, how, and how to get the strategy and implementation strategy, the perspective to get the information more about cloud migration, about migration, application, technology, process, and governance. Okay.
Sorry for the interruption, but you have left
Yes.
only 2 minutes. Kindly conclude it.
Sorry. The potential use of the cloud computing is growing in the telecommunication industry. Also, the benefit of the cloud computing consists of tangible benefit and intangible benefit. Tangible benefit and in the business context refer to benefit that can be calculated directly. For example, reducing cost, increasing productivity and reliability. Intangible benefit that don't have physical and difficult to measure, like core competency, data security, agility, scalability, and customer satisfaction. Wait. In the yes, this cost benefit analysis is one of the there are some risks that explained in ISO 31000. There are possible risk response strategy to like negative risk, avoid, transfer, mitigate, accept, and also positive risk, exploit, enhance, share, acceptance. And cost benefit analysis is a risk assessment technique that help users select or decide which option that to take a risk, can identify, can apply in risk identification, risk analysis, and evaluation. The cost itself is the cost of cloud computing, utilizing some resource provided the cloud service provider. This expense company rents charges associated with the virtual machine storage and data transfer. The cost itself consists of the adoption, procurement, migration, operational, usage, exit. The component is strategy, organization, and so on, data export. And the benefit also is we can see we divide five things, like operational excellence to see the effectiveness of the operational, and the security, how to handle the security in the cloud, the reliability, about the application availability and performance and so on, productivity, about the development life cycle, work culture, and so on, and the cost itself, the expand that the spend from the customer, the organization. There are two things, benefit, tangible and intangible. Tangible, it's not, it can be calculated with the cost or something measurable and quantified, but intangible is something that we cannot measure, like productivity, client trust, brand reputation. Also, if we move to the cloud, we have to consider the intangible benefit that more than the intangible, because yeah, we can see that we have to save the confidence of the client, trust, brand reputation, competition advantage, customer loyalty, and so on. In this work, we can, after we calculate the cost and the benefit in the company or organization, we can see the cloud itself can increase productivity by up 67%. How fast the software development process, like because in the on-premise infrastructure we can everything doing by manual, like development, deployment, and provisioning the infrastructure. That is manual and can increase the human error, but in the cloud we can use it scalability, more scalable and more flexible with the cloud. Also, organization can reduce time to develop new product and accelerate time to market and respond quickly to market change. The benefit of and also the benefit of managing risk and security, include increasing security feature in the cloud computing. This security risk and security and risk can avoid maybe 60% loss revenue caused by data and security leaks. For cost optimization, it can reduce up to 5 to 2% and increase performance by up to 231%. From productivity, it can accelerate the software manufacturing cycle by 67%. From operational standpoint, increase the system availability and avoid loss of revenue caused by system downtime. This is the Loan and McLaren success model. We divide into 5 factor: F1, F2, F3, and F4. The F1 is the use of cloud infrastructure due to various benefits like migration of application, scalability, and flexibility, reliability, faster responding time, high availability. This is we calculate the data from the application and the performance and the scalable flexibility in the infrastructure, something that we can get benefit from the tangible benefit. And then factor 2 is cloud with automation and orchestration. With the automation and orchestration, we can more handle automated transaction, not doing manually by human. And then this can increase productivity and agility, operation efficiency with the automation and orchestration. F3 is cloud real-time streaming event, reduction of bridge, higher customer experience with 5% aligned to local regulation, higher productivity. And the factor F4 is efficiency and security, improve the scalability and flexibility, cost reduction in the security software, increase in security, higher transaction volume, and efficiency gain. In the end, this research revealed that part of from the cost, there are also benefit factor, both tangible and intangible, which help analyze the feasibility of migrating the cloud computing. Theoretical model are valid for adoption of migration of cloud computing, so that organization can understand the implication and benefit. This is the Loan model. Infrastructure quality can there are relation between information quality and usage implementation with the F1 factor, and F1 factor like use of cloud infrastructure due to various benefit, and this impact of tactical ISUs can be considered with the cloud with automated and orchestration. And the impact of operational ISUs is related with cloud real-time streaming event. And the result of the benefits after we analyze the usage implementation and user satisfaction, we can see in the efficiency and the security itself. Okay, I think that's my presentation. Is there any question maybe? Wait.
Perfect. There are two
Okay.
questions in the chat box.
Okay.
Kindly answer that question.
Okay. uh, in this analysis, actually we use some comparative in the data in behind. Yeah, this is a global. This is a global picture of the different with the on-premise infrastructure and the cloud itself. On-premise infrastructure, we have to uh, invest in the first, but the usage it's not effective. There are a gap, but in the actual demand, maybe we don't use the maximal usage. We can use based on needs or pay per use based on the business need. So this is can be cost efficiency in the long term if we use the cloud. And this is the we have some calculation. I'm sorry, in this is in Indonesia, but we can translate into English. This is the budget to provide the current infrastructure or current infrastructure that used by company. But this is the budget for the cloud computing, and we can see the budget itself can reduce. Then the budget itself is cheaper than the current infrastructure. Okay. Cost analysis is based on the quantitative cost analysis is two things ya Pak. Sorry, wait. Yes. Cost benefit analysis is two things. The number one is the cost itself can be quantitative. We can calculate or measure the cost itself, but the benefit itself it's qualitative, like trust, brand reputation, competitive advantage of using the cloud itself. We can combine the qualitative and quantitative. In this case, qualitative and quantitative. Yeah. For example, government spend budget to make infrastructure for the country, but the infrastructure country is more cost to spend, but they don't consider only cost itself or something that we can measure. They consider also the benefit itself of the infrastructure, like can make a transportation mobility and can increase economy, productivity, people and so on. So I think the cost benefit analysis is two things, consists of the cost itself that can be measured, and the benefit something that cannot be measured, or like qualitative good or no, brand reputation good or no, client trust or no, and so on.
Mr. Tawfiq, thank you so much for your
Okay,
presentation.
okay,
It
thank
was
you.
such a nice presentation.
Uh, I can, sorry, I stop the presentation, Pak.
Now I would like to call Norton to present his paper on From Industry 4.0 to Industry 5.0, Challenges and Opportunities in the Testing, Inspection, and Certification Industry. You may
Oh,
please start your presentation.
yes, thank you very much. Let me share my screen first. Oh, my screen. All right. So my presentation is from Industry 4.0 to Industry 5.0, and the challenges and opportunities that bring to the testing, inspection, and certification industry. So my presentation outline is first we come across with the changes in the 21st century, and then what Industry 4.0 bring us, and then we describe a little bit about Industry 5.0. What is that? And then we talk about our TIC industry, the testing industry, and what the challenges the industry is facing in the change of the environment, and then what we can do in order to adapt the changes in the Industry 5.0 that bring us. Okay, so the changes highlighted in the 21st century, including the change of working behavior and the post-pandemic world, because people are not trying to work 9 to 5 at the office, and they would like to have more time, more work-life balance, working at home, or also. So the working behavior changed, and also because of the political and economic crisis, people would also start to think, is technology good for human nature? How can we use technology in a good way such that it help people rather than it is killing people? Okay, the third thing is the need of green and sustainable world to meet the decarbonization policy in the year 2050. Because of the Paris Agreement in 2016, it means that every country and every nation has to fight to work for the decarbonization targets to become net zero in 2050. And it is a long way to go. And actually, we are working through that. So the changes is how we can make the world a greener place to live in, and how we can reduce carbon dioxide emission is becoming a more and more hot topic in the 21st century. So we have the Industry 4.0, which help a little bit, and that is about using technology. No, in Industry 4.0, as proposed by the German government in 2016, was an advancement, and the key enabling technologies would be the cyber physical systems, cloud computing, AI, big data, and these enabling technologies help the manufacturing plants or help the world to promote their productivity, to increase the efficiency of productivity, and to bring along all different parties of the supply chain to give out better quality products and better services. And that is the concept of Industry 4.0. Then we are moving all the way towards Industry 5.0. Industry 5.0 was first proposed by the European Union in 2020. It is not focusing on the productivity, rather than it use technology. How do we use technology to more focus on the mankind in human-based? So we look for the three major topics of Industry 5.0. They are sustainability, workforce protection, and knowledge and talent management. So sustainability, we have to make sure our world is the temperature is not rising anymore and become a sustainable world for our future generations. And workforce protection is because of the there are more and more technologies coming out. Actually, in the past, in the 1980s or 1990s, there are a lot of work or careers which has some dangerous or health affecting positions that can be replaced by the machines or by technologies now. So with the enabling technologies in Industry 5.0, we are more looking into how do we protect the workforce in our work environment. And then the knowledge and talent management, because of the knowledge is always growing very quickly, and there are lots of new technologies coming out, the wireless communications, and then there are more concerns on the cyber security. So there are lots of different knowledge that appears in the 21st century. How can we manage that? How can we make sure our knowledge is well aligned or well structured for our next generations to get into the latest latest information? That is the important point that we are focusing in the Industry 5.0. So here is the comparison, the short comparison with the Industry 4.0 and 5.0. 4.0 is more focusing on the technology side. How do we use technology to make sure our product is more of high quality, more reliable, and our services as well. But 5.0, Industry 5.0, it focuses more on human, the benefits of human, the benefits of the Mother Earth, and how can we protect them? How can we make sure our next generation is growing up in the sustainable world? So this is the difference between Industry 4.0 and 5.0. Then we have talked about how the technology is changing. But now, is there anything to do with the industry I'm studying? The industry I'm studying is for the testing, inspection, and certification industry. This industry is an industry keeping the gate of the products and service compliance to ensure products and service consumers related are received as in safe, environmental friendly, reliable, and with high quality. So think about an iPhone. If we want to sell the iPhone to different countries, we have to do the test. We have to make sure the battery will not explode or catch fire. We have to make sure the use of RF spectrum is good. So this is the industry keeping the gate by carrying out laboratory experiments. So with the changes from industry 4.0 to 5.0 or whatever, what is the industry facing as a challenges or opportunity? The first challenge we will say is the new regulations is ever coming out. As a rule of thumb, we know one standard comes out every 7 minutes in the world. So this standard governs different things, including cybersecurity, including chemical, including food and safety. So with this information is booming up, the industry is looking for a need of solution, how to manage those or how to organize this know-how. And the second thing is for the new, there are also new standards regarding the new green energy, sustainability auditing, and carbon auditing. These are new types in the testing domain. We need new talents, new people. How can we keep the new talents or new people in our industry is also a major challenge for the industry we are facing. All right. So the difficulty is also in transforming the working environment, because for the laboratory we are stick to the laboratory equipment. We are also stick to all the rules inside the laboratory. It is very hard to work from home. All right. So how can the technology help people in the industry working a more like work-life balance life? That is also another point, that we have to keep the talents inside the industry, and instead they are writing programs and doing their work from home, and the industry is keeping the people out of the industry. It is not a good thing. So knowledge management is also the other thing. The more standards, people are hard to learn the standards with well-organized manner, and that is another
So Norton,
Yes.
sorry for the interruption, but would you kindly consider concluding your presentation?
Yeah,
As we have only left with last 2 minutes.
Sure. And then to solve this problem, or to look into this problem, how can we use technology with Industry 5.0 and enabling technology in order to tackle that? So we have three dimensions. The first one is the use of the augmented reality and virtual realities with these touchless sensors in order to help the people to learn the process, because there are lots of technologies that is dangerous during the testing process. If we can make a digital twin in the laboratory session, helping engineers understanding the lab procedures, helping them to organize things, that would be more like a support to them to get the testing knowledge much quicker. So that's the first thing. The second thing is to use the AI and able to certification information, because for the testing and certification environment, there are 150 more countries, and we need to organize the certification information better. With the use of AI, when a product is tapped into the system, we can use our knowledge database in order to grab the required certification information to the user, and then it can help them a lot in increasing the productivity and efficiency of the testing process. And then with the help of the 5G networks, it enable the the online working of the user of the clients that is remotely in other countries. They don't need to travel all around to the laboratory to visit and walk in the test to see the testing. And then also for the energy optimization of laboratory, they can use AI to make the energy optimization such that the power consuming sessions of the task will be moved to the midnight, which the electricity bill is lower. So this kind of different enabling technologies can help the TIC industry to face the industry 5.0 such that it becomes a more human-oriented and more concerned in the knowledge management, and ensure the world to be a sustainable world to live in. So this is a kind of my a little bit sharing about the point of view of the latest technology that can be applied into our testing, inspection, and certification industry. So thank you very much for your attention, and that is my presentation today.
Mr. Norton, there is a question in the chat box. Kindly answer that question.
Oh, so what is the outcome of my study? Actually, my study brings out that technology can help the industry to tackle the challenges the industry is facing. For example, now we are building up the system to help the engineers of the industry in order to gain the practical experience through the AR and MR. So these are all the foundation study that what the industry is looking for in order to tackle the challenges it is facing, and later on we are actually building those systems in order to use the technology to help the industry out.
Thank you so much, Mr. Norton. It was a
Okay,
nice
thank you.
presentation. Moving forward,
All right.
Mr. Norton, there is another question in the chat box. Kindly answer that question in the chat box itself. So moving forward, now I would like to call SM Mizanur again with another paper title, Human Trust Between Real and Virtual Agents for the Real World Assistive Task. You may please start your presentation.
Okay, thank you. Can you see my slide?
Yes, sir.
Okay, thank you very much. Okay. So human trust between real and virtual agents for a real world assistive tasks. My name is Mizanur Rahman. I am from the Pennsylvania State University at Scranton campus, USA. So, so let us see this slide actually shows, I think that why it is now, yeah. So this slide shows some the robot. You see that there are some social robots. So the social robots can be used for many social purposes. in the human society. For example, social robots can help disabled people to perform different activities at their homes. So there are many activities of social robots in home and offices and in human societies. And also we have another type of social agent that is called human virtual human. So virtual human is a virtual human is a virtual agent generated in the software. It cannot come to the real world, but it can interact with the people from virtual world or from software. So if we compare between these two agents, so there are many similarities between these two agents. Similarly, there are many differences also between these two agents. So our question is that the social robots and virtual humans need to be more interactive with humans. So our current analysis says that the social robots and virtual humans should be more interactive so that they can help human perform different activities. And another new idea is that we may see a collaboration between social robots and virtual humans. Social robots exist in the society in the real world, but the virtual humans, they do not exist in the real world. They actually, they exist in the virtual world. But how can we make collaboration between these two agents of different realities? What is the way, or whether there is any way to establish collaboration between these two agents of heterogeneous realities or different realities? So that is a question, and we are trying to answer the questions in this paper. And another question is human trust in social robots and virtual human, and how human develops trust, his or her trust in the social robots and virtual humans. Because if the human cannot trust the agents, the human will not be happy with the services or assistance provided by the social robots and the virtual human. But the question is, if we want to model the human trust, then the question will be, what are the factors that can help us or that can influence the trust modeling? So if we model trust, then at first we have to identify the factors of trust, or what are the factors that influence human trust in social robots and virtual humans. And another question is whether there are any differences in the trust factors between social robots and virtual humans, and whether there is a difference in human trust between the social robots and virtual humans for the same real world activities. That means how human perceive his or her trust in social robots and virtual human for the same work performed by two different agents. So in this, to answer these questions, our objective of this paper is to identify trust factors for social robots and virtual humans for a real world collaborative tasks with humans, and also investigate the difference or similarity in human trust between social robots and virtual humans for the same collaborative tasks. So these are objectives. And in order to address those objectives, we have two different agents. We have a now robot. This is a social robot. And we have a virtual human that we developed. These are our robot and this is our robot and our virtual human. So I used this robot and virtual human for many of my previous research, but the objective of this research is different. So we have developed a now robot that can perform some real world activities. For example, it can move, it can walk, it can point something in the real world. And the virtual human we have developed, it can also do some activities. For example, it can move inside the software, and from the software or the virtual world, it can point something in the real world to help human finding something. If something is missing, it can direct or it can point at something at the real world from the virtual world. So then we have developed an experimental scenario where the virtual human and the robot can face each other. And here we have some boxes where we can hide an object. The objective is that the virtual human and the social robot, based on the previously taught knowledge, they will try to explain how a human can find out the missing object. So this is the object, this is the experiment, and that means the robot and the virtual human can assist a disabled human or a human who can pretend as a disabled human in finding a missing or a hidden object in a real world environment. So this is the experiment, and in this experiment we will try to understand how the human perceives the trust factors between for the virtual human and the now robot or the social robot for the same task, and whether there are differences in the trust factors perceived by the human, and whether the human can trust the virtual human more than the social robot, or whether the human can trust the social robot more than the virtual human for the same task. That we want to understand based on some subjective evaluation or questionnaires set for the human. So then after this experiment, we found some results, and this table actually shows major trust factors and the category, frequency, and mean rating, showing a relative importance in generating human trust, with a standard deviation in the parentheses of each trust factor of the assistance provided by the social robot. For example, these are the trust factors that were proposed by the participating human subjects. So these were actually the human subjects wrote the trust factor or the factors that can influence their trust based on their perception. They wrote it on the paper sheets provided to the human, and based on their information, the researchers actually categorized the trust factors, and these are the categories. For example, accuracy in performance or function or action, efficiency of performance or function or action, attributes, quality of gestures and actions, attributes, quality of gesture and actions, embodiments. So these are some, okay. So then these are some actually the category based on the factors proposed by the subjects. And frequency means out of 20 subjects, how many subjects proposed this category as a factor of trust. For example, 20 means 20 subjects out of 20 propose that the accuracy in performance should be a trust factor. Similarly, 16 means out of 20 subjects, 16 subjects propose that efficiency of performance should be a trust factor. Similarly, 13 means quality of gestures and actions should be a trust factor. That was proposed 13 subjects out of 20. And mean means, so we ask the subjects to express the importance of that factor to generate trust. For example, when the subject proposed that accuracy in performance should be a trust factor, then we also asked the subject to rate it in a scale between 1 and 5. 1 means the least important factor, and 5 means the most important factor. The mean data means the average of the rating of 20 subjects, like this. So then we get this. So this table, this is an outcome of our result of our research. It can clearly shows that. So these are the factors that can generate trust in the human as perceived by the human subjects participated in this in the study. So if we use more subjects, the results may be slightly different. But based on the subjects who participated in the study, based on their perceptions, and particularly for these tasks, these collaborative tasks, we think that these are the factors that can influence the trust of the human. And this is for the social robot, and we got a similar table, not exactly same, but similar table for the virtual human. So these two tables show that there is almost no difference in the perception of a human for trust factors. That means the trust factors for the social robot and the trust factors for the virtual human were almost similar. That means human perceive the social robots and perceive the virtual human in the same way for receiving their assistance. That means humans trust or the factors that can influence humans trust are not too much different between these two different agents. They perceive in the same way. However, for this particular tax, we also used a subjective rating scale that is called the Likert scale. We also asked the human that whether they how much trust they have for the social robot and how much trust they have for the virtual human for the same tax to find an object in the real world based on the instructions of the social robot and the virtual human. So based on their results, we see that so this is the main
Mr. Mizanur,
results. Yes.
sorry for the interruption, but you have left with only 1 minute. Please conclude your
Okay.
presentation.
Okay, thank you. So I will do it soon. So then we see that the human trusted social robot more than the virtual human for the same tax. We tried to understand the reason that social robot has better embodiment or presence in the real world, but the virtual human does not have that presence. We believe that, or we think that the difference in embodiment may be a reason of higher trust for the social robot and lower trust for the virtual human. So then this is our conclusion that I have already explained. So in the future, actually, we will study how human trust in artificial agents can help us compute artificial agents' trust in human. We will also propose different trust-based advanced control and decision-making strategies for various human agent collaborative tasks. And as we now know the factors affecting humans' trust for both robots and virtual human, we will try to propose a computational model of human trust in virtual human and social robot based on the factors that we learned in this study. So this will be our future work. So then there is a question. What is the frequency? I have already explained that out of 20 subjects, how many subjects mentioned that this should be the factor? Or their wording may be different, but I tried to understand the meaning because different people wrote in the different ways, but we categorized based on, because we have to have the same category. We understood the meaning, and based on that, we understood or tried to understood how many. Okay, so then how do you include context and emotion? Context and emotion, actually for this case, I think that we do not have any particular emotion for this case. So we do not have actually, yeah, usually virtual human and social robot may have emotion. For example, they may laugh, they may express sorrow. But in this case, we put the standard one. That means no additional emotion. That the normal face. For example, it was more clear for the virtual human, but it was not so clear for the now robot, because now robot is a hardware. It is difficult to create emotion, but it is slightly easier for the virtual human to create. But in our case, it was a normal move. We did not have any particular emotion, but it is true that if we have different emotion, that might impact humans' trust. That means that can be another research, that how emotion of the agents can impact the perception of humans' trust in different agents that we did not consider here.
Any other questions from chair?
No, thank you.
I guess there is no question. Let's move forward. Thank you, Mizanu, for your presentation. Moving forward, now I would like to call Firin. to present his paper on Protectionism by Government, the Retrenchment of Globalization and National Security. You may please start your presentation. Towards a closing remark, I sincerely thank our author for their excellent presentation contribution in this session and all participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the seventh version and all the previous six versions of the conference. We will be happy to have you in the eighth version in 2024. All the presenter would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to Springers. The publication will be live within 6 months. Kindly cooperate with the team of WS4 2023. I also want to thank Professor M. Tamim uh, and Professor Vivek Tiwari for chairing the session, a token of appreciation to the chair on behalf of the team World S4 2023 and the Global Knowledge Research Foundation and partner. Thank you for your valuable presence. I request all the participants kindly switch on your camera for a quick snapshot of this virtual conference. Thank you so much.